Okay, we're going to be looking at an experiment here to see if we can measure both the change in momentum and the impulse that is experienced by this trolley. You'll notice that this trolley has what we call a picket fence on the top. As it goes through this light gate, we'll be able to measure with the data logger the speed of the trolley as it approaches this force meter at the end. When it hits this force meter, the data logger again will record the force as it increases and then decreases as the trolley moves back. Again, as the trolley goes through the light gate, it will measure the speed, but we know that the speed will be the velocity in the opposite direction. Okay, let's see if we can take this data here. I'll just start the data logger collecting and try to gently move the trolley through there and move it back. Now if we just have a brief look at the data as it appears on the screen here, you can see that this top diagram here indicates the force that is experienced by the force meter, increasing as the plastic belt on the front compresses and then decreases again. I've used the data logging facility to actually calculate the area under the force graph. We know that that's equal to the impulse. That's the equivalent of you counting up squares underneath a graph. And again, you can see here that as the trolley hits the force meter, the impulse increases up to a maximum value. On the bottom here we have two measurements of the speed. That is the speed as the trolley is approaching. That is the speed as the trolley is moving away from the force meter. And so we know that the speed of the trolley as it hits the force meter will be somewhere in between. We'll have a look at the data using the PowerPoint.